Have you ever stopped to think how incredible it would be if we could stop the rain with a laser? Imagine the scene. You're about to leave the house, and instead of grabbing an umbrella, you simply activate a device that vaporizes every drop of water before it hits the ground. It sounds like a science fiction idea, doesn't it? But is it really feasible? Let's explore this fascinating possibility and discover the challenges this technology would face. The idea of using a laser to stop the rain is undoubtedly intriguing. However, upon closer inspection, we realize that executing this idea is much more complex than it first appears. To begin, we need to consider the amount of energy a laser would need to vaporize water. Did you know that vaporizing just 1 liter of water requires about 2.6 megajoules of energy? Now, imagine an intense storm dumping 1.25 centimeters of rain per hour. If we do the math, the energy required to protect an area of 1 square meter with our laser would be an impressive 9 kilowatts. To give you an idea, that's almost 10 times more energy than the Earth's surface receives from the sun. But it doesn't stop there. Water has an incredible capacity to absorb energy. To heat water to boiling, you only need about 10% of the total energy. The other 90% is needed to transform the water from a liquid to a gas. This means that by trying to vaporize water, we'd actually be filling the air with an immense amount of hot vapor. And let's face it, no one would want to live in a human-sized autoclave, right? Now, let's talk about the trickiest part, vaporizing a water droplet with a laser. While the idea seems simple, the reality is that it takes a colossal amount of energy applied quickly to vaporize the droplet without simply shattering it into tiny particles. Have you ever seen how a droplet reacts when hit by a laser pulse? It's fascinating, but most of the time what happens is that the droplet fragments rather than vaporizing completely. This leads us to believe that we would actually need even more energy than we already consider absurd. And what about laser targeting? In theory, this could be solved with advanced technology, perhaps even without the need for military equipment. High-speed cameras are already capable of tracking the position of moving objects, like a baseball, hundreds of times per second. A similar system could, in theory, be developed to track raindrops. But that's not all. Adaptive optics, which allows for rapid and precise control of light beams, would be essential. To cover an area of 1 square meter, we would need about 500 direct pulses per second. That's a considerable technical challenge. Now, you might be wondering, what if we decided to simply fire lasers in random directions? How far could a laser beam travel before hitting a raindrop? That's an interesting question. The answer is that, just like rain, you can see quite a distance, perhaps several hundred meters. So if you're thinking about protecting your entire neighborhood, firing random lasers wouldn't be the ideal solution. In fact, it could cause more problems than it solves. So what can we conclude about this idea of stopping the rain with a laser? While it's a fascinating proposal full of potential, the reality is that we're far from making it a practical possibility. The amount of energy required, the technical challenges of vaporizing water droplets, and the complexity of laser targeting make this idea more of a dream than a reality. What do you think? Do you think we'll one day see technology that can control rain? Or will this idea remain the realm of science fiction? Leave your opinion in the comments. And if you like this video and want more content like this, don't forget to subscribe to the channel and turn on notifications. Let's explore more incredible and challenging ideas together.
Den Kommentaren. Und wenn